Hey guys, welcome back. Today we are doing your last and final type of chemical reaction, which is going to be double replacement reactions. Now, the good news is double replacement reactions are very similar to single replacement, and for these, we don't even have to use an activity series. So actually, the single replacements are a little bit more difficult, so this should go pretty quick today. So far we've talked about all the different types of chemical reactions. We've done synthesis, decomposition, combustion, we did single replacement, and now today we're doing double replacement. Again, just like with your single replacement, you could also see this called a double displacement. It just means the same thing. And here is our objectives for the day. After today's lesson, we should be able to identify double replacement reactions, predict the products, and also be able to balance out our chemical equations, which at this point we're getting pretty used to. Okay, so first let's talk about predicting the products of a double replacement reaction. So what is a double replacement? This is when two compounds react to form two new compounds, okay? So if remember, in a single replacement, you had an element and a compound on the left, and then an element and a new compound on the right. The difference between single and double is that with a double replacement, you're going to have two compounds on the left and then two compounds on the right. They've basically just flipped what elements they're bonded with. Okay, so we're going to do a switcheroo in both of these compounds. So here's our common form. Compound plus compound will yield a compound plus compound. So AB plus CD will yield AD plus CB. So you see in this example, the A and the C are the same, and then that B and that D have switched places. So in this example, those compounds have just switched who they're bonded to, essentially. Okay, so you can always tell the difference between single and double replacement because, again, in single replacement, you'll have an element and a compound. In a double replacement, you'll have two compounds. So let's take a look at an example. We have copper 1 sulfate plus beryllium oxalate. Okay, so these are our two compounds. Remember, just like yesterday, like is going to replace like, or I should say just like in our last lesson. Like will replace like. So metals will replace nonmetals, metals will replace metals, and nonmetals will replace nonmetals. Sorry, I got a little tongue tied there. So metals will replace metals, nonmetals will replace nonmetals, like will replace like. So here, copper and beryllium, these are both metals. They're going to be the switcheroos, right? So, and the good thing for this as well is that we don't have to use the activity series for these reactions. So remember, with a single replacement, you had to look at the activity series. You had to look, okay, which one is doing the replacing? Is it high enough on the activity series to go forward? You don't have to worry about that here. You just have to be able to identify that these elements are switching, okay? So copper 1 sulfate plus beryllium oxalate will give us copper 1 oxalate and beryllium sulfate. Okay, so all you're doing is changing, in this case, the polyatomic that the metal is bonded to. Okay, they're just switching partners essentially. So if you were, let's say you were in a relationship, right? You have a significant other, and let's say your best friend was also in a relationship with a significant other, and you guys decided, I like your boyfriend or I like your girlfriend better than I like mine. Let's go ahead and switch them. That's the same thing as a double replacement. So you're basically just switching the partner that you're with. Okay? It's like kind of like a dance, right? And so here is just some examples. The first one is going to be a single replacement. So if you see here, we've got potassium and water. And remember, water you can write as hydrogen hydroxide. So the potassium and the hydrogen will be switching around. But you can tell that this is a single replacement in the first one because, again, we have an element and a compound, and then an element and a compound. So you'll have an element and a compound on the left as is the right. That's your indication it's single replacement. And then if we look at the bottom, we have a double replacement here. So again, the calcium and the sodium have switched places, and now they are bonded to their opposite anion compound, okay? So here we have the calcium now with the CO3 and the sodium with the C2H3O2. Okay, that's a double replacement. And again, you can easily identify that because you've got two compounds on the left and two compounds on the right. Okay, that's the easiest way. So with double replacements, you do not have to worry about the activity series. They're going to proceed forward. We're just going to assume it. Make sure you're paying attention. Today's assignment, you guys are going to do just a quick checkup to see if you can identify the different types of reactions. So again, there's synthesis, where something is created, decomposition, where a compound will decompose into smaller elements. And then remember, with decomposition, those are the only types of reactions where you end up with more than what you started with. Okay, that's a key thing about those decomp reactions. You have combustion reactions where you have a hydrocarbon as your fuel source plus oxygen will yield CO2 plus H2O. So that's the only one that can get kind of tricky, especially when you're doing replacements and combustions. You just need to make sure when you're looking at the reactions, if there's oxygen and a hydrocarbon on the left and CO2 and water on the right, it's a combustion reaction. Single replacements, you start with an element and a compound, you end with an element and a compound. Like replaces like, so metal replaces metal, non-metal replaces non-metal. Remember, for the single replacements, you have to use the activity series. And then, of course, today, this double replacement, they're replacing each other. They're switching partners. You'll have compounds on the left and compounds on the right. Okay? So your activity today will be straightforward. Go on, move on, and complete that. But of course, if you have any questions on anything at all, let me know. And if not, congratulations, you have made it to the end of your chemical reactions unit. From here on out, it is studying, and then we'll take our test.